All right. We are going to talk here about a few unique DNS situations. I wasn't quite sure the best way to call this. DNS scenarios, challenges, things that you might come across if you're administering an Active Directory domain that has Active Directory integrated DNS and you need to manage your own DNS zones. What we're going to cover here are three things. We're going to talk about split horizon DNS, and that is where you've got an internal server that is hosting a web application that is available externally. So it does have a public DNS name, but you have clients internally that need to resolve it, and you end up running into a challenge because internal clients trying to resolve an external IP that's probably pointing back on site is going to cause an issue. So we'll talk about that a little bit. Split brain DNS is actually something that's pretty common. Usually occurs when you have a company that has their domain name internally the same as their domain name externally. So this would be like you configuring your Active Directory domain for business.com and your public website is also business.com, and this presents a couple of challenges because your internal clients trying to resolve business.com are going to get internal IP responses from your DNS server, so you have to manage those a little bit differently than you would if you have a different internal DNS name. The other thing we'll talk about is how to resolve DNS connectivity between domains that have local network connectivity. There's a couple different ways of doing it that we want to think through. And then I'm also going to mention some Windows DNS load balancing options. I will probably do another quick video talking about Windows DNS policies because that's kind of a new thing. And this is going to be more of a whiteboard session video. So let's jump into that. Our first slide here, or first whiteboard paint session, is going to be on split horizon DNS. We mentioned what this is already, but just to go over it, this is where you have an on-premise Active Directory domain. That's kind of indicated here in the black box. In this case, the domain DNS zone is business.local, and this company has an external website called business.com. Now, for the sake of example, their public IP address here is 5454, and we're going to assume that that public IP address is associated with their physical location where they have their domain. So their office has a static public IP address. It's 5454. They have a public website called business.com, and they have an internal domain at that physical location called business.local. Now, this split horizon scenario happens when they are hosting a website, or they're hosting a web application on a server that they have on-prem. So in this case, this is represented here by this server, app1.business.local. And in this scenario, we're going to say that this server is hosting a company or a web application called Portal. Let's just say this is used by technicians out in the field and also needs to be accessed by office staff internally. That's kind of their web portal for their managed business application. Now, what's going to happen here is if you are external, if you're a client that's out here, you are going to go to portal.business.com and you are going to get the return IP 5454, and it's going to connect. And that's actually going to connect you in through a firewall, NAT rules, whatever, to app1.business.local. And that's going to be just fine. However, if you are a client that is, let me just change my box here. Let's say this is your workstation right here, and you are internal. If you were to try and go to portal.business.com, what's going to happen is you're going to go out to the public internet. You're going to see my DNS record for portal.business.com. You're going to get a return address of 5454, and it is going to try and route you back here. The problem is that is your public IP address you're coming out, and you cannot route traffic outbound and back inbound on the same address. So this is going to fail because you can't do outbound and inbound. So this is actually a pretty simple fix, but it does require a little bit of DNS maintenance. The way we fix this, just as a label, client. All right. The way we fix this is we are going to publish different DNS zones. So, oops. Let me set my font size something a little bit bigger here so it's easier to read. Got to be careful with the Paint text editor apparently. Okay, so we have our business.local zone, right? That has an A record for oh my gosh, this keyboard is not working in Paint. App 1 that points to 10.0.0.30. Okay, so that just represents this scenario right here. We've got the business.local DNS zone. It has an A record for our App 1 business server, and that's pointing to 10.0.0.30. Now, what we are trying to fix is the workflow from client to business.com, because that's what's not going to work. And in this scenario, we've got to do two things. We have to create another DNS zone on your DNS server, and that's going to be business.com. Now this is simple. This is so that you have an authoritative response. You can control the response that your clients are using at the DNS server that they're connecting to. Because remember, by default, your DNS server acts recursively for any DNS zone it doesn't host. So a client trying to get to business.com is going to go to your DNS server. I know this is going to represent the domain, but let's just say, for instance, this is your DNS server. It's going to go to your DNS server. Your DNS server is going to say, I don't have a zone for business.com, so it's going to go out to the internet, however you have it configured, whether through a forwarder or through your root hints. It's going to resolve business.com. It's going to get the public IP address from your DNS registrar for that zone, and it's going to return that public IP, and that's where it's going to fail because the network can't go out and back in the same IP address. So what you're doing here is you are telling your DNS server to say, okay, I want you to own the zone for business.com. You are going to be authoritative for that zone now. So now you can control the responses that you get from that zone. So your client's going to go to your DNS server instead, and it's going to say business.com, and your DNS server is, yes, I own that zone. What record do you need? And all you're going to do is create a record for portal. Well, just to match what we've got, an A record, and that's going to be for portal, and that's going to resolve to your app, same IP address as your App 1 server, because that's the server that's hosting the address or the website. 10.0.0.30. There you go. And what that's going to do is your client is going to go to your DNS server. It's going to say, do you have a record for business.com? And business.com is going to say, or portal.business.com, and the server is going to say, I own the business.com zone. You're looking for portal. It's at 10.0.0.30, and you're going to connect that server. That's how you resolve split horizon DNS issues. All you have to do is create the zone and then map your internal IP address to whatever subzone is trying to resolve. Now, this is going to come with its own challenge as well, because what's going to happen here is you are going to be able to resolve portal.business.com because of this record. But if you think about it, your company owns business.com. It's probably not only using that DNS zone business.com for portal. It's used externally for your clients or for your staff, but you probably also have a website at justbusiness.com or www.business.com. And now when you've created that business.com zone on your internal DNS server, what's going to happen is any requests for business.com are now going to be responded to by this. So if your internal server doesn't have a record for at, meaning a blank domain for just business.com, or www for www.business.com, any requests to that website are going to fail. So in that case, you are also going to have to create records for, these are also going to be A records. These keyboard shortcuts in Paint are going to mess with me. At means this is just business.com, and you need to map that to whatever the public IP address, because chances are you're hosting that website externally. So you would ping business.com, get your response, and let's say that website's hosted at that public IP address. And let's say you want to resolve both business.com and www.business.com to the same thing. You just create two records. Same IP address. And now business.com, www.business.com, and portal.business.com would all be correctly resolved by your internal DNS server because it owns that zone. Now, this also means any other sub zones or other records in the business.com zone you're also going to need to manage. But that becomes pretty straightforward because all you have to do is ping it to get the IP address and then create records to map that. And then you also hope that whatever service is hosting that is not changing IP addresses dynamically, which is probably unlikely for a business website, but it's possible. So it does come with a challenge of having to administer more DNS records in an additional zone, but that's how you deal with split horizon DNS. I'm going to go ahead and clear this up. Our next scenario we're going to talk about is split brain DNS, which is very similar but slightly different. Split brain DNS is rather than having a separate internal zone and an external zone with different names, you actually have your internal domain name mapped to your external domain name, or it matches. So in this case, going back to the same example, we have business.com. It has portal.business.com as the website, and your internal domain name is also business.com. Now, this scenario is actually going to be pretty similar. Let me just copy my... Oh, I lost the client icon. All right, I'll create a new one. That's fine. So, create our client again. In this case, let's think about what happens if you're trying to resolve portal.business.com. And let's assume you don't have a record for it right now. So client goes to DNS server. It says, I need portal.business.com. The DNS server's response is, I own business.com. What record are you looking for? And the client says, I'm looking for portal.business.com. And the DNS server responds, I don't have a record for that. So tough luck. This is pretty easy though, because if you think back to our split horizon DNS example we just talked about, all we had to do to make that work was, let's recreate our little chart here. Okay. I'm going to type really slowly to get Paint to cooperate with me. And let's expand this as well. You have a business.com zone. I don't know what records you have right now, but what record we're looking for is portal. So all we have to do is create an A record for portal. And let's say it's pointing back to that same server, app1. That's going to be, in the last example, it was 10.0.0.30. So we'll do the same thing, 10.0.0.30. Now, this zone is already, because it's an internal zone and your clients are assumed to be registering to that, this is also already going to have a record for your server. So you can do it like this, and you're mapping now portal to that IP address. So any requests are going to go client, I'm looking for portal.business.com. That returns 10.0.0.30, and now the client goes over here, assuming the IP for this is 10.0.0.30. That's one way to do it. If you have some sort of application load balancer or some sort of I'm blanking on the word, some sort of function on the application side that is dependent on the domain name to be right. Meaning if you have an HTTPS certificate for portal.business.com and it's on this server, this is the way you have to do it, because you have to resolve the name directly to portal.business.com. However, it's most likely this is going to be the case as well, because chances are this server is still hosting external copy of it as well. Now, if you don't have that, another way you can do that is, instead of doing an A record for portal to that IP address, you have the option of doing a CNAME record instead. Paint as a whiteboard tool is not the best. You could do a CNAME record to app1.business.com. And what that's going to do is, obviously, the client's going to query, I want portal.business.com. Oh, I didn't do this right. Hold on. That CNAME record is for portal. and that points to app1.business.com. So you're saying, client says, I want portal.business.com. That's saying I own business.com. You're looking for portal. That's a CNAME. It's actually an alias for app1.business.com. So instead, the client is going to go, instead of just the IP, it's going to go to this server, which returns the app1.business.com DNS record. It's going to get that response back of 10.0030. Like I said, it's a little bit more dynamic in the sense that if app1 is ever going to change, that record will automatically change as well, because if it changes IPs, you're only managing one DNS record to map the name to IP. However, it comes with the additional consideration of it probably won't work to resolve HTTPS or certificates, or if you have any sort of name-based load balancing or application routing happening, it's going to fail because you're not resolving the name directly. You're actually resolving app1.business.com instead. That's split horizon DNS. Now, I think there's some wiggle room there. I actually could be wrong about that, but because I know with some load balancers, you're creating CNAME records for the VIP, which resolves to the actual name, but I think it depends on the CNAME record. It also depends on your DNS server and your DNS records. All right, third scenario. We were going to talk about resolving DNS between local domains that have network connectivity. So in this scenario, we're talking about two companies here, let's say, or two domains. I don't know if they're separate companies or not, doesn't matter. We have widget.local on the right, and we have gadget.lan on the left. I had those backwards. Widgets on the left, gadgets on the right. In this case, these domains can talk to each other. They have network connectivity either through a VPN or local connectivity if they're in the same building. Who cares? They are able to connect with each other's domain using a local connection, not through the public internet. The way this works is you want DNS to be able to resolve both ways. So let's assume that gadget.lan purchased widget.local, and in this case they're keeping the domains separate. This would be a common reason why network connectivity might be established if one company owns the other, but you need DNS connectivity to work between the two. So there's two possible ways to think through this. If possible, the simplest way to do this would be you have a DNS server here at, let me change the size, at gadget.lan, right? My paint layers are messing up. One second. There you go. All right, you got your DNS server at gadget.lan. Let's say you are on widget.local and you need to make sure that any DNS requests to gadget.lan work, meaning you need to be able to look up the domain name for any client that's on gadget.lan. If that's the case and you have full network connectivity and you don't have any sort of firewall rules or traffic blocking it, what you can do is, the simplest way to do this is configure your DNS server for widget.local. You're not configuring the zone itself, but oh my gosh, this paint. I don't know what keyboard shortcuts are messing up or what's doing it. DNS server for widget.local. What's the mechanism for next steps in resolution? Meaning, if you're trying to resolve a domain that isn't owned by this DNS server, it isn't authoritative, what's its next steps? If you think about it, there's two options. We've talked about this in the review video. You can either configure root hints, meaning I will go figure out each level of the domain to get my response back to you and figure out what that DNS lookup is recursively, or your other method is to use forwarders, meaning if I don't own the zone and I don't know, my next step is to send your request on to some external forwarders that aren't hosted by us. My preference is always to use forwarders in general because of DNS caching, but in this case, that's the simplest way to get this working. Because rather than using your ISP forwarders or a different external forwarder like Cloudflare or Google DNS, what you can do instead is you set your forwarders to be gadget.lan. So let's just say, for the sake of this example, the DNS server for gadget.lan is, we actually already have this. So down here, the DNS server for gadget.lan is 10.0.0.5. It says right here. So I want to set my forwarder to, and this would be, these hotkeys in Paint are ridiculous. This normally you'd have 2 DNS servers, but let's, for the sake of this example being easy, we're just going to have one forwarder, 10.0.0.5. Now, what's going to happen is, let's say you are on web.widget.local, the server, and you say, I want to get to google.com. Your request is going to go to widget.local. Do you own google.com? It's going to say, no, I don't know google.com. So its next step is going to be, what's my forwarder? My forwarder is 10.0.0.5. So I'm going to go to the DNS server at 10.0.0.5. Gadget.lan says, now Gadget.lan, do you own google.com? He's going to say no, and he's going to go to whatever his next step is, whether forwarders, internet, whatever. But then he comes back with the google.com IP address, sends it back to widget.local, who then sends it back to the client who's trying to resolve it. So in this case, you're just using this as your next step. And the cool part about that is that works for your internet traffic. But if you think about, okay, now I need to resolve something on the gadget.lan domain. Okay, let's say I'm trying to get this server IP address. So web.widget.local goes to its DNS server. It says, I don't own the gadget.lan DNS zone. I'm going to go to my forwarder. My forwarder is 10.0.0.5. And it says, I'm trying to get to db.gadget.local. It checks its records. It says, I own the gadget.lan domain. That DB is 10.0.0.20. So it's going to send that response back to the DNS server, back to the client, and now the client knows to connect, bam, to db.gadget.lan. So it handles both external internet traffic and also handles routing for any internal domain resolution to the gadget.lan domain. Now, the last step that's missing in this piece is DNS resolution would work one way, but it would not work the other way. So the fix for that is then you add on the DNS server for gadget.lan. You wouldn't add a conditional, or you wouldn't add a forwarder. You would use what's called a conditional forwarder for the widget.lan, widget.local domain, and that points back to the DNS server on widget.local, which is 192.168.1.2. And what that's doing is, if the gadget.lan, let's say this client db.gadget.lan, someone's on the server and it's trying to resolve web.widget.local, it's going to go to this DNS server. The DNS server says, you're trying to get to widget.local. I have a conditional forwarder to that, so I'm going to send you to this IP address over here. Widget.local is then say, I'm trying to get web.widget.local. It's going to say, oh, I own that IP or that DNS record. Here's its IP. It's going back to gadget.lan, and then it connects to the server. So it's kind of the exact same thing in reverse, but in this case, rather than all of your traffic going back to this DNS server and it being kind of a recursive loop back and forth, you're only saying traffic that's trying to resolve widget.local goes to this DNS server, rather than all of the traffic. So going one direction from widget to gadget, all DNS queries are going here. Going the other direction from gadget to widget, only DNS queries for widget.local are going back. And that way you're using forwarders and conditional forwarders to do full DNS resolution between both the domains. That is one way to do it, and that's probably the correct way to do it in almost every case. However, there are instances where maybe you don't want to do full DNS cutover for whatever reason. I don't know exactly why that reason would be, other than let's say there's some sort of DNS or network conflict and that's not going to work. But let's say that exact same situation, you do need to do resolution for certain resources on the gadget.lan domain. So let's say, for this example, You have an application, web.widget.local, that needs to resolve a database that's on db.gadget.lan, but you do not have full DNS connectivity yet, but you do need to be able to resolve the name because there's something name-based that's required. This is a really uncommon scenario, but it might happen. In this case, the easiest way to do this to get resolution working for single resources is very similar to the split horizon configuration. We're going to go back to our DNS server on widget.local, and rather than making a gadget.lan domain, which will break any queries going to that for any resource on gadget.lan that we don't control, or you'd have to manually manage a copy, what we're actually going to do is create a zone for the single resource that we need to resolve. So in this case, we need to resolve db.gadget.lan. So our zone name is going to be db.gadget.lan. And in that zone, we're going to have an A record. It's going to be the @ symbol, meaning this is blank. So no subzone, I want that to resolve to, and whatever that server IP address is, 10.1.0.20. Now, if this client says, I need to get to db.gadget.lan, it talks to its DNS server. The DNS server says, oh, that's a zone. I have a record for just that zone with no subzones. Here's the IP address, and it can connect, 10.1.0.20, based on that zone. This gets a little, it doesn't scale super well, because if you have to start resolving more and more clients on the gadget.lan zone, or in the gadget.lan domain, you're going to have to manage separate zones for each one of those clients. So it's not going to be a super great solution, but it is good as a temporary placeholder if you need to do single resource lookups by DNS without having full DNS connectivity. So it's a good stopgap. Our last section here was going to be on DNS, Windows DNS load balancing, and this is going to specifically talk about DNS policies that are new to Windows. I'm going to do that in a next video because that's going to be a little bit more of a demo, hands-on lab. I'll see you in that next video.